Okay, so we want to do 33 in section, where is this?
11.6.
11.6. Okay, cool. So it says, in exercises 33 to 36, use the given graphs to
solve each equation.
Good, solve. Okay, so here's my kind of picture they drew for me, right? They drew, all right, we've got f of x is 8 to the x plus 2 over 3. You guys see that? So that's this one. Does that match what it should look like? Okay, let me think. I remember that those things look like this, right? This is the kind of generic f of x is b to the x, where b is bigger or smaller than 1?
Bigger.
Bigger than 1. 8's bigger than 1, so this seems like it agrees with my intuition, right? Okay, so I'm kind of cool noticing that. What do they mean f of x is 16?
That means the y is a constant.
Yeah, that just means the constant output 16, right? That's a kind of a dumb rule, right? That one takes an x that you give it and just pitches it and gives you 16 back, right? So I'm wondering, when does the rule g, or why did they call these the same thing? I'm going to call that one g. So when does the rule f match the rule g, right? So it matches it kind of here, right? But what does here mean?
Some point up.
Okay, that's a point, right? What's the x value at that point?
It appears to be 2.
Yeah.
Seems like it's 2, assuming the picture is good, right? What's the y?
Something.
16.
It's 16. How do I know it's 16?
Because y is
It
always
tells
16.
Because it's on the red line, and the red line says y is always 16. You guys see that? How else could I find out it was 16?
By being really good measurements.
By trying to measure? No. I could guess it was 16 by trying to measure. I could plug x equals 2 into the other rule. You guys see that?
Yeah.
Because it's on the blue one, it's a point that's an x comma f of x pair, right? So it should be a 2 comma f of 2 pair. Is f of 2 indeed 16? What do you think? f of 2 is 8 to the
4 over 3.
4 over 3. What's 8 to the 4/3 power?
Well, 8 cubed was 2, and then 2 to the 4th power is 16.
Close. So 8, not cubed, but
Cube root.
cube root. So the cube root of 8 to the 4th, right? This is 2 to the 4th. Ah, indeed, that is 16. You see that? So when I'm solving this, right, what do I write down? Do I write down 2 comma 16?
No, you write.
Yeah, they're just asking for an x value, right? You guys see that? They're asking for which output do these two rules agree. These two rules agree when that input is, sorry, I said that wrong. For which input do these two rules agree? They agree when the input is 2. You guys see that? That's where the graph's from. Cool. Should we do the other one next to it? Okay, so let's do the other one next to it, just because we're here. Oops, eraser. So how about the other one next to it? The other one next to it says I've got this thing. Okay, so I'm looking for this dot, right, where the two rules agree, right? What do I think that dot probably is?
3, 9.
Yeah, I think it's probably 3, 9. I should probably check. How do I check?
You put 3 to the 27 to the 2.
Yeah, put 3 in for the x here, right? So I'm looking at 27 to the,
2 over 3.
see, 6 minus 4 is 2 over 3. Right, so this is f, I suppose, of 3. And that's this, and this is
3 squared. Or cube root of
3, right? The cube root of 27 squared,
which is 9.
which is 9. Check. Good. So what do I write?
X equals 3.
X equals 3. Good. Cool? Yep. So every time you're solving one of these, there is a graphical interpretation for it, right? They're sometimes a bit hard to draw because I don't really know all my shifting rules yet. But in chapter 12, we're going to get the shifting rules, and then we'll just know how to graph them. And then we can use these to get approximations. You could actually use your graphing calculator now to get approximations if you can get the order entered right. Cool? All right. Awesome.